Right, so thank you for staying with all the way to the end, everybody. I wanted to talk to you about our nanofibers and our work on air filtration and basically toughening composites. What we are is a company that operates in this space of R&D, nanofiber customization. We're taking basically stuff from university TRL3s, taking them all the way up to about 5 or 6, depending on the application and what the request is. We did talk about electrospinning, and I know there are some presentations, but for the benefit of those of you that do not know what electrospinning is, it's basically what we have here. Sorry, I'll just turn my pointer option on. We have a syringe needle here, and using a high voltage, we pull very thin strands of fibers out of this droplet, which get deposited onto the substrate. So typically voltages are around 20, 30 kV, 5 kV, 10 kV, depending on the solution. And really the know-how and the challenge of all of this is in developing the solution and making this stable, but also doing lots and lots and lots of these fibers. So the applications are varied. You can go from anything from making PVDF sensors. So these are piezoelectric energy generation and sensing, and we have projects at the moment working on fetal monitoring. You can make these nanofiber substrates that are very good at healing, so you can wrap wounds in them and they speed up healing. You can load them with medicines. Obviously, filtration is one of what I'm going to talk about today, so I'll spend more time a little bit later. But we know, for example, that you can improve sound absorption significantly. But the one that we've, if you want, sort of started the company with and pushed through was that if you put veils of nanofibers on composites, on carbon fibers, basically in between them, you can reduce by about 20 to 30% the number of layers you need at the same strength, or you can improve the strength of those composites. So talking about ourselves, this is our first rig. We are operational, and probably it's worth saying that we have started and made all of this during the lockdown in the UK, which lasted a long time, and it really couldn't be done without having 3D printers and all sorts of things like that. But we are now operational and have been operating for a while in Guildford, just outside, just next to the University of Surrey. So we were very lucky in getting some funding. We had one of the best rated proposals with Innovate UK to look at protective equipment. And I have to say that one of the interesting things that I've discovered today is that we've been in the single-use filters or low-use filters, and it's an interesting challenge on how you make a filter work for 3,000 to 5,000 hours. But just to show what we're doing, so we have a particular know-how in this case, so we'll be making lots of filters here. What's different about our filters is that they carry a lot of static electricity, and I think the last speaker has shown to you how important it is to have this charge in your filtration systems. And basically it's just the way your fluffy duster works. That's just the classic ostrich feather fluffy duster. Now our nanofibers, just to put them in context, they're on a non-woven substrate, so we typically have less than 1 GSM of nanofibers on non-wovens. We can load them and have loaded them with copper oxide, with graphene, and with silver. To be honest, graphene seems to be one of the better materials out there to load them with. So we then went to testing, and our testing is done in the Global Centre for Clean Air Research, which is a small research facility at the University of Surrey. And basically this is their business end, this combustion, which it's a fast particulate analyzer going down to single-digit nanometers. They have a nebulizer, a potassium chloride, same as everybody else. And as you've heard before, the particles we test for are sort of from just a little bit above 10 nanometers up to about 300 nanometers, because our challenge was to stop particles below the 100 nanometer level. So what we did is we put our filters on an NHS mask. We have a commercial partner that have their own nanofilters. These are put on a charcoal, and then we put our nanofibers on it. So to cut a long story short, we've got, as I said, this is the distribution of the nebulizer. So we throw these particles. I wouldn't really go trust that much around there, but sort of this area is sufficient. And just having a single layer of nanofibers, as you can see on the NHS mask, we have something around the 80% mark stopping the filter, stopping the nanoparticles. Particularly in this range where the coronavirus is around the 60 nanometer mark. Of course, what you do learn very, very quickly is that the more efficient your filter is, the quicker it gets blocked up. So, you know, when we look at the time and the pressure increase, and I have to say this is, if you look at the medical standard, they always talk about pressure per unit area. So we are just about in the type 1R sort of limit, allowed limit on the in the standard. The NHS mask certainly becomes more 80% particle filtration. And remember, this is just our first prototype, our first layer of nanofibers that we put down. We have put it on the on our commercial partners mask, and we achieved 87%. Again, this was the first try. Since then, we've gone to independent testing, Nelson Labs near Utah. We're also doing testing with MPL to validate our results, but we are very close to 99%. So just to conclude, as I said, I've given you a very, very brief overlook at our key results, particularly electrostatics. Nanofibers are efficient at trapping nanoparticles of very low GSM, but not all nanofibers. You need to find the right formulations, the right materials. If you make an efficient filter, it will block relatively quickly. So this is a catch-22. How do you make efficient filters? We know anecdotally that when people developed nanofiber filters, the users ended up punching holes through them because they couldn't, they didn't fancy changing them that quickly. Of course, with masks these days, this isn't a problem because they're single use. We are working now with a large area manufacturer for tests. So we're going to get our first roll of 1,000 square meters back in February. And we ourselves are now up at 4 meters squared per day. And with some luck and some investment, we will scale up our IP to 1,000 meters squared per day. And we aim for that to happen in the middle of 2022. So anybody's got some spare cash, then maybe we're a hot investment at the moment. So this is the team, the original team, save quite a few people. There's myself, Simon, and Rob Yates, who are our co-founder, and Emily, who basically does all the hard work and is responsible for our good results of recent. So I just wanted to leave you with some other interesting pictures about nanofibers. These are ultralight sponges. This is not my work. This is Andreas Greiner in Bayreuth. But just to kind of show you a little bit of an experiment. Oh, and this video is not sort of playing, I'm afraid. It was meant to show you the old-fashioned experiment where if you have two bits of paper coming down to a highly static surface, they pull apart. So anyway, you can look up on my LinkedIn profile and see that video. That's it. Thank you very much for watching. And if you've got any questions, either contact us. We're very happy to talk about customization projects and doing R&D for nanofibers. Thank you.